Today we're going to learn how to solve systems of equations using the substitution method. You should be on page 24 in your notes packet. Some systems of equations are better solved through a method called substitution. You can identify these systems because they will have a variable that has a coefficient of 1 or an equation that can easily be changed so that a variable has a coefficient of 1. So, for example, in this equation that says y plus 5x equals 13, and this other equation that says 3x minus 8y equals 27. You can see that in this first equation, y has a coefficient of 1. That means that it would be easy for me to get this equation so that the y variable was by itself on the left side. All I would need to do is get rid of this 5x by subtracting 5x from both sides. To solve a system of equations by substitution, the first thing you would do is solve one equation for one of its variables, which means that you either get x or y by itself. Next, you substitute the expression that was found into the other equation. Then you solve that equation. Finally, you substitute the number in for the variable in the original equation so that you can find the value of the second variable. Once you have the value of both variables, you would write your answer as an ordered pair. You do always want to check your answer by plugging your x and y values into both of the original equations to make sure that they are correct. It is very important when you check your answer to make sure that you check it with both equations and not just one. If you check with just one equation, chances are that if you made a mistake with an equation, it will check out in one of the equations but not the other. Here's an example. X minus y equals 1 and 3x plus 2y equals 8. In this first equation, I can see that my x has a coefficient of 1. Y has a coefficient of negative 1, so I'm just going to try to get x by itself. So if I use x minus y equals 1, I know that to get rid of that minus y, I would use the inverse, which would be adding y on both sides. Well, my negative y plus positive y would cancel, and I'm going to bring down x equals. Well, on this side, I have 1 plus y. Well, that's the same as saying y plus 1, or I could just write it as 1 plus y because it's not going to change anything. But since my y had a plus sign in front of it, I know that's a positive y, and since 1 was positive, I could put plus 1. Now, doing this and getting x by itself means that even though I don't know the actual value of x, I know that x's equivalence is y plus 1. What I can do is I can take y plus 1 and I can put it in the other equation and substitute it in for x here. Well, this equation says 3x plus 2y equals 8. We know that 3x means 3 times x, but I now know that x is the same as saying y plus 1. So I am going to replace or substitute this in for x. So instead of 3 times x, I'm going to say 3 times y plus 1. And then I have the rest of my equation, which is plus 2y equals 8. Now, I just solved my equation. Now, this is a multi-step equation, which means I've got to do several steps before I can even use inverse operations. I need to simplify the left side of my equation. So the first thing I need to do is use my distributive property. I'm going to do 3 times y, which gives me 3y, and then 3 plus 1, which gives me positive 3, so I would write plus 3. Then I need to write the rest of my equation, which is plus 2y and equals 8. At this point, I can still not start using inverse operations because you can see that I have like terms with 3y and 2y. Well, this really says 3y plus 2y, so I'm going to put those together to get 5y. That plus 3 did not have a like term, so I would rewrite it, and then all of this still equals 8. Now that both sides of my equation are simplified, I can start using my inverse operations to solve. So the first thing I want to do so that I can solve for y is to subtract my 3 from both sides of my equation. The 3's cancel to leave us with 5y equals, and 8 minus 3 gives us 5. Now to get y by itself, we can see that it's being multiplied by 5, so we'll use the inverse, which is dividing by 5 on both sides. Well, these will cancel to leave us with y equals, and 5 divided by 5 gives us 1. So now we know that the value of y is 1. Since we know that y is 1, we can take that and plug it into either equation. And that's important. I typically choose the first equation, but it doesn't matter. You should still get the same or the right answer no matter which equation you put this in. So if I use my first equation, that one said x minus y equals 1. Well, now we know that y has a value of 1. So instead of x minus y, I'm going to say x minus 1. And then the rest of the equation is still equals 1. Well, we're just solving for x, so we need to get rid of this minus 1 by doing the inverse, which is adding 1 on both sides. These will cancel to leave me with x equals, and 1 plus 1 gives me 2. So that means that the value of x is 2. Well, remember that our solution is always an ordered pair. X comes first, y comes second. So our solution to the system would be 2, 1. You can always, and you should always, check your work. When you check your work, just like I said before, you have to check both equations. So with equation 1, we had x minus y equals 1. Well, our x value is 2 minus our y value, which is 1, equals 1. 2 minus 1 is 1, so we have a solution that is correct. However, you have to check with both equations because, again, if you made a mistake, it will show up as correct in one equation, but you'll find it in the other equation if you made a mistake. So you have to check both. So this says 3 times x, so I'm going to do 3 times 2, plus 2 times y, so I'm going to do 2 times 1, equals 8. 3 times 2 is 6, 2 times 1 is 2, and if I add 6 plus 2, I get 8. So because it works for both equations, I know that this solution is correct. Now let's try some more problems. Our first equation says 3x minus 3y equals 33 and 4x minus 2y equals 16. Well, unfortunately, with both of these equations, neither of them has a variable that has a coefficient of 1. Because of that, I'm going to have to just take one of them and change it. So what I usually look for is I look for a variable that's probably positive because that sometimes makes it easier. So a variable that has a positive coefficient, well, x has a positive 3 and x here has a positive 4. But then what I also look for is that the coefficient on this x is 3. And I want to ask myself, can everything else in this equation be divided by 3? Well, 3 can be divided by 3, and 33 can also be divided by 3. So since everything in this equation can be divided by this 3 from this x, I'm going to say, you know what, let's start and let's use that. So 3x minus 3y equals 33. Well, I want to get x by itself because it's my positive variable, so it'll be easier. I need to get rid of my minus 3y, so I would add 3y on both sides of the equation. These would cancel, and I would get 3x equals. Well, then I have 33 plus 3y. Those are not like terms. I cannot put them together. So instead, I would write it as either 33 plus 3y, or I like to write it with my variable first, so 3y plus 33. Now, x is still not by itself, so you see that x has to be divided by 3, so we would divide by 3 on both sides. Well, that leaves us with x equals, and remember, when you have to divide like this on this side of the equation, every term has to be divided by that 3. Well, 3y divided by 3 is 1y, or that's the same as just y. positive 33 because I know it's positive because of this plus sign. So 33 divided by 3 gives me 11. And since it's positive, I would write plus 11. So even though I don't know the value of x now, I do know that it's the same as saying y plus 11. So what I want to do here is make sure I substitute it into the other equation. We don't want to put it in the equation we just had, so we want to put it in the other equation. Well, the other equation that we didn't use before is 4x minus 2y equals 16. Well, remember 4x means 4 times x, but now we know that x is the same as y plus 11. So instead of 4 times x, I'm going to say 4 times y plus 11. And then the rest of this says minus 2y equals 16. Well, now we have to solve our equation. So again, this is a multi-step equation. So we would need to start by distributing our 4. 4 times y gives us 4y. 4 times 11 gives us 44. And then we have minus 2y and equals 16. We need to combine our like terms. So we have 4y minus 2y. 4y minus 2y gives us 2y, and then we still had 44, which didn't have a like term. Now this is a two-step equation, and now we can solve by using our inverse operations. We are going to first subtract 44 from both sides of our equation. So these will cancel to leave us with 2y equals. Well, if we do 16 minus 44, we get negative 28. Now, y is still not by itself, so we need to divide by 2 on both sides of our equation. These will cancel to leave us with y equals, and negative 28 divided by positive 2 gives us negative 14. So now we know that y is negative 14. Now that we know that, we can plug that back into our original equation. So our original equation said 3x minus 3y equals 33. Well, now we know that y is negative 14. So this is 3x minus 3 times negative 14 equals 33. Well, remember, this really says negative 3 times negative 14, so you have to make sure that you pay very close attention to the fact that that's negative. Negative 3 times negative 14 actually gives us a positive 42, so we would really write 3x plus 42 equals 33. Now to solve, we would subtract 42 from both sides. These would cancel, and it would leave us with 3x equals, and 33 minus 42 would give us negative 9. Then, to get x by itself, we would divide by 3 on both sides. These would cancel, and we'd get x equals, well, negative 9 divided by positive 3 is negative 3. So again, we always want to write our answer as an ordered pair, and you have to remember that x comes first. So our solution is negative 3, and then y is negative 14. Then you want to make sure that you go back and check your answer. Again, you want to check it in both equations. So check your answer now and make sure that it's correct. Next, we see 8x minus 10y equals 10 and x minus 5y equals 20. We can see that in this second equation, our x value has a coefficient of 1. That means that that equation would have an easy time of getting x by itself. So let's start with that equation. So x minus 5y equals 20. If I want to get x by itself, I just need to get rid of minus 5y. So I would add 5y on both sides of the equation. Well, these would cancel, and I'd get x equals, and then I have 20 plus 5y, or that's the same as 5y plus 20. Now that I know what x is, I can take that and I can plug it into my other equation. Well, the other equation was 8x minus 10y equals 10. So instead of 8 times x, I know that x is actually 5y plus 20. So I'm going to say 8 times 5y plus 20. Then the rest of this says minus 10y equals 10. Now we solve our equation. Again, it's a multi-step equation, so we're going to start by using the distributive property. 8 times 5y gives us 40y. 8 times positive 20 gives us positive 160. And then the rest of our equation says minus 10y equals 10. We want to combine like terms, so we have 40y minus 10y, which gives us 30y, and then plus 160 equals 10. Now that both sides are simplified, we use inverse operations to solve. So we would subtract 160 from both sides. These will cancel to leave me with 30y equals, and 10 minus 160 gives me negative 150. Now to get y by itself, we are going to divide by 30 on both sides. These will cancel to leave me with y equals, and negative 150 divided by positive 30 gives me negative 5. So that means that y has a value of negative 5. Well, we can plug that into our original equation. The original equation that we used was x minus 5y equals 20. So instead of y, I'm going to say x minus 5 times negative 5 equals 20. Well, we want to be careful here. So we haven't done anything with the x. We'll rewrite that. But this is a negative 5 because that minus 5 means it's negative. Negative 5 times negative 5 gives us positive 25. Since that is a positive 25, we actually want to write plus 25 and then equals 20. Well, now to get x by itself, all we have to do is get rid of this plus 25 by subtracting 25 on both sides. These would cancel and we have x equals, well, 20 minus 25 gives us negative 5. So what we notice is that in this equation, both x and y have a value of negative 5. So our solution is negative 5, negative 5. Next, we see 7 plus y equals 5x and negative 3x minus 2y equals negative 12. You can see that in this first equation, our y variable has a coefficient of 1, so we could get y by itself. So we're going to say 7 plus y equals 5x. And to get y by itself, we need to get rid of this 7. Well, 7 is being added to y, so we are going to subtract 7 from both sides of our equation. These will cancel to leave us with y equals, and then we have 5x minus 7. Well, now that we know that that's what y is, we can plug that into our other equation. Our other equation says negative 3x minus 2y equals negative 12. Well, that's negative 3x minus 2 times y. But this time we know that y is 5x minus 7. And then all of this equals negative 12. Well, now we're going to solve. Again, it's a multi-step equation, most of these will be, and so you'll have some work to do before you can start using your inverse operations. Well, we have negative 3x, there's nothing we can do with that yet, but now we need to distribute, and when you distribute, you have to be very careful with this equation. This is not a 2, this is a negative 2, because it says minus 2. So you have to do negative 2 times positive 5x, and negative 2 times negative 7. Well, negative 2 times positive 5x gives us negative 10x. Because it's negative, all we write is minus 10x. That shows us that it's negative. Then we have negative 2 times negative 7. Well, negative 2 times negative 7 gives us positive 14. Because it's positive, we would write plus 14. And then the rest of the equation says equals negative 12. Now we combine like terms. Negative 3x minus 10x gives us negative 13x. So now we have negative 13x plus 14 equals negative 12. Well, to solve, we're going to start by subtracting 14 from both sides. These will cancel and we have negative 13x equals, well, negative 12 minus 14 gives us negative 26. Now to get x by itself, we are going to divide by negative 13 on both sides. These will cancel and we get x equals, well, negative 26 divided by negative 13 gives us positive 2. So that means that our x value has our x coefficient or variable has a value of 2. So we plug that into our other equation. So our other equation was 7 plus y equals 5x. Well, instead of x, we're going to replace that with 2. So 7 plus y equals 5 times 2. Well, 5 times 2 is 10. And all I need to do to get y by itself is subtract 7 from both sides of our equation. Well, these will cancel, and I have y equals 10 minus 7, which is 3. So now there's nothing else to solve, and I know that x is 2 and y is 3. But you, again, need to make sure that you go back and check your answer. Our last system of equations says y equals negative 2 and 4x minus 3y equals 18. Sometimes you'll see a system of equations that looks like this. Well, this already has y by itself. So instead of making this hard for myself, I'm going to say, okay, I'm going to use this. Not only is y by itself, but there are no other variables in that first equation, which means there's nothing else to even solve. I actually already know that the value of y is negative 2. So I don't need to solve for y, I just need to solve for x. So I'm going to substitute the value of y, which is negative 2, into my other equation. So 4x minus 3y equals 18. Well, so that means 4x minus 3 times y, but we know that y is negative 2. Now we just solve. So we have 4x, and then we have negative 3. Remember, that's negative. So negative 3 times negative 2, which gives us positive 6. Because it's positive, we would write plus 6, and then equals 18. Now we solve our equation, so we subtract 6 from both sides. These cancel, and we have 4x equals, well, 18 minus 6 is 12. And to get x by itself now, we are going to divide by 4 on both sides. These cancel, and we have x equals 12 divided by 4, which is 3. Well, at this point, we normally would substitute this back in so we could find y. But we know y, so we're not going to do this step. What we now know is that x is 3 and y is negative 2.